Section 6.5 is all about rhombi and squares. So get this set up into your notes. Section 6.5, rhombi and squares. So first, a couple of definitions. A quadrilateral is a rhombus if and only if it has four congruent sides. So a rhombus, the plural for rhombus is rhombi. You probably remember some other plural words that end like that. For example, many cactus are cacti, many octopuses are octopi. So you get the idea. So here we have a rhombus. We see all sides are congruent, but all the angles aren't necessarily congruent. Now a rhombus is a parallelogram, a special type of parallelogram, and as a result, all rhombi share the special characteristics that parallelograms have. For example, opposite sides are congruent, obviously, and they're also parallel. The opposite angles are congruent, so the reds are equal and the blues are equal. The consecutive angles are also supplementary. In other words, red plus blue equals 180. The diagonals bisect each other. And then two new properties. The diagonals are perpendicular, and also each diagonal bisects the opposite angles. In other words, the two red angles are cut in half, and the two blue angles are cut in half by their diagonals. Those are two special properties of rhombi. Parallelograms do not have those characteristics on their own, but special rhombi do. So fun things about rhombi are rhombial tilings. You've probably seen these before. They're sort of optical illusions. They look like they're maybe in 3 dimensions. So for example, here we've got kind of a stair-stepping type of pattern. Here's sort of more of a star-shaped pattern if you look at the darker blue. Here's a slightly different star-shaped pattern. They're just so much fun to play with. Rhombi and rhombi and rhombi, all over the place. So one other definition, squares. We're probably all familiar with a square, but in terms of strict definition, a quadrilateral is a square if and only if it's both a rectangle and a rhombus. Remember, rectangles have right angles, and rhombi have congruent sides. So a square must have both right angles and congruent sides. So let's look at an example. Here I've got a rhombus. Maybe I'll call it RHOM, for rhombus. And let's say I draw in the diagonals. Now let's say angle HRM is 82 degrees, and I want to find angle HMO. Well, remember, consecutive angles are supplementary, so that means angle RMO is 98 degrees. And then since each angle is bisected by diagonals, I know that unknown red angle must be 49 degrees. For our second rhombus example, let's say we've got our diagonals sketched in, and that little angle is 3x minus 10. The other angle is 5x plus 20. How would you solve for x? Give it a try if you want to try, sort of test yourself. Remember, since diagonals are perpendicular, that bottom triangle is a right triangle. And we know all 3 angles. 3x minus 10 plus 5x plus 20 plus 90 all together must add up to 180. And so therefore x is 10. Let's look at one more example. Here we have a square, and let's cut it down its diagonals. And let's say one of those corner angles is 2x minus 13. Now remember, squares are rhombi, and rhombi have bisected angles. Also, squares have right angles, So we have right angles that are bisected. In other words, 2x minus 13 has to equal 45 degrees, half of 90. So therefore, x is 29. Here we have a few more examples. Label the missing coordinates. Let's say this quadrilateral, Iowa, is a square, and the only information we have is that point W is D0. Well, I know that that length must be d units because the x-coordinate of W is d, which means because all sides are congruent, point I is at 0d, and likewise O is at dd. Here we've got a slightly different example. Here we've got a square that kind of straddles the y-axis, and we've got a length here of k units. It's k in the negative direction, and because this is a square, right, it's given that this is a square, I know that this length is going to be 2k units tall. So the y-coordinate for r must be 2k. Likewise, since it's symmetrical over the y-axis, point F is k0, and O is positive k, 2k. Here we've got a rhombus, and none of the points are labeled, so we can kind of decide what we want to label them. Remember, rhombi have bisected angles, bisected diagonals, and the diagonals are perpendicular. And so in this case, we're using the x-axis and the y-axis as the diagonals for the rhombus. And so this distance from the origin to point A must equal the distance from the origin to D. And so if we say A is at, let's say it's B0, then D, the point D must be at negative B0. Now similarly, because H is the same distance from the origin as N is, if we say H is at 0k, then N must be at 0, negative k. Here's another way to look at rhombi. Let's say we had rhombi TOES, and point E is at 0j. Point O is at k0. That's enough information to fill in the other 2 points. Because O is k units from the origin, I know that the diagonal is 2k units long. Likewise, because E is j units tall, I know that the other diagonal is 2j units long. And so the coordinates for point S are k, 2j, and the coordinates for T, 2kj. Let's look at one coordinate proof. Let's say we want to prove that if we have a rhombus, then its diagonals are perpendicular. And we'll use the previous rhombus, TOES. So we're given that that's a rhombus. We want to prove that TE is perpendicular to OS. Well, how do we prove anything is perpendicular? We use the slope formula. We want to prove that the blue segment is perpendicular to the green. So using slope, we'll show that. So the blue segment, TE, has a slope of 0. The green segment, OS, has an undefined slope. We're dividing by 0. So segment TE is horizontal because its slope is 0. Segment OS is vertical because its slope is undefined, which means therefore segment TE is perpendicular to OS.